Question we're going to have a look at using the internal resistance in calculation. So just to start with, it's asked you to find the EMF of a battery, or define it, sorry. So we know voltage, or just in electricity in general, you want to define using equations, and voltage is energy over charge, energy per unit charge. EMF is a certain type of voltage. It's the voltage of all the components in the circuit added together. So we say it's the total electrical energy produced or provided by the cell per unit charge. So let's write that out. Total energy provided by this, you can say cell or battery, but in this case in the diagram there's a cell, which is why I mentioned cell, and then per unit charge. Right then, moving on to the next part of the question. When the switch S is open, there's infinite resistance and it reads 8 volts. So when the switch is open, the voltmeter reads the voltage across the cell itself, which is the voltage provided to the whole circuit, that 8 volts of EMF. So this is the EMF. When the switch is closed though, it says the voltmeter reads 6 volts. What that means is, because the switch is now closed, the current will flow through this resistor here. So the voltmeter now, instead of reading the voltage across this cell, it now reads the voltage across this resistor. And it's told us that the voltage that flows through this resistor is 6 volts. It's asking you to find the current in the circuit when the switch is closed. You can find the current in the circuit by finding the current through this resistor. They're both the same because this resistor is in series with the whole circuit. And so I've written a prompt here. We can rearrange this equation to get current is V divided by R. So the voltage that flows through this resistor is 6, and the resistance through that resistor is 2.4. Dividing those together, you get 2.5 amps. So that's the current flowing through the whole circuit. Great. Now let's use that in the next part of our question. Show that R equals 0.8 ohms. Now whenever I ask you to find internal resistance, you always want to think of this equation here. Now the EMF is the total voltage provided by the cell, which is 8 volts. And that's equal to the terminal voltage, which is the voltage that flows through every component except the internal resistance. So it's like the voltage that flows through everything in this circuit except this section of the circuit, which is just the voltage through this one component, 6 volts. And we add onto that the lost volts, which is the voltage that's wasted because current has to flow through the internal resistance to flow through the rest of the circuit. So just by rearranging, we get current times the internal resistance is 2 volts, because 6 plus 2 is 8. We also know the current is 2.5 from previous calculation, so we can say that the internal resistance is 2 divided by that 2.5, which is what gets you that value of 0.8 ohms. So that's the answer to that. It says the switch now remains closed, so it's going to be closed, meaning the voltage across this would be 6 volts, and the amount of voltage wasted is 2 volts, like we mentioned here. Find the power dissipated in this resistor. Well, there's an equation for this on your equation sheet. I'm just going to change pen color since we're moving on to a different question. But we know the current that flows through this resistor. You found that it was 2.5, or we found it was 2.5. We also know the resistance across it, and we can find the power using the equation P equals I squared R. So we multiply the current by itself, so we square it, and then we multiply by a resistance of 2.4. Multiplying all these terms together, you'll get a value of 15 watts. That's the answer here. Now it asks for the total power dissipated in the circuit. So for that, we need the total values of whatever we use. For example, the total voltage provided by the whole circuit, we know that that's 8 volts. We also know the total current flowing through the whole circuit. So we can find power using the equation power equals current multiplied by voltage. That's the current of 2.5 that flows through the circuit, multiplied by the EMF, which is the total voltage in the circuit, that's 8 volts. 2.5 times 8 is just 20, so that's 20, and then the unit is watts. Now I ask you to find the energy wasted in the battery in 2 minutes. The reason why energy is wasted is, like I mentioned, current has to flow through the internal resistance, and this is wasted because it doesn't reach the actual useful part of the circuit. We know energy is power multiplied by time in seconds, power in watts. We need to find the power that's wasted because of this internal resistance, which is the current that flows through the internal resistance, again 2.5. By the way, we're going to use IVT here. I'm going to write that step because power is current times voltage. So the current through the internal resistance, which is 2.5, multiplied by the voltage through the internal resistance, which is 2 volts, multiplied by the time taken in seconds. So we take that time in minutes, then you multiply by 60. Multiplying all those terms together, you'll get a value of 600 joules. And that's everything for this question. If you have any questions, just let me know in the comments. Otherwise, thanks for watching. Please like the video. And I've linked my email in the description too if you have any tutoring inquiries.